Everyone, it is the 5th anniversary of PyTorch. So we have a very special slate of guest stars today. We've got Yann, Lin, and Soumith, who are going to talk to us about the beginnings, the middle, and the future of PyTorch. Welcome to Schroepfer, y'all.
Thanks for having us.
It's fun to be here.
All right, let's start the very beginning, Yann. I'll let you decide. Are we going to talk about 2012 or are we going to talk about the 90s? Like, where should we start with AI frameworks?
The 80s, actually.
The 80s.
Yeah, I mean, when I was doing my PhD, I wrote a couple, neural net simulators, and the second last one I wrote, I ended up writing kind of a script interpreter for a script language, and I figured, why invent my own language? Why not kind of use, a language that already exists? So I got together with Leon, who was still an undergraduate student at the time, who was actually finishing his master's. And we wrote a neural net simulator, the two of us, on our Amiga computers, that's going back 1987.
No way!
Yeah, I was a big fan of that. And it was a Lisp interpreter that we wrote, that Leon wrote mostly, hooked up to kind of a numerical backend library. And then I moved to Toronto, then I moved to Bell Labs, and Leon finished his PhD, and this thing kind of grew and grew, and eventually became kind of a complete Lisp development system with a compiler and everything, and it had a matrix engine or tensor engine in the backend, and automatic differentiation of the type that you see now in some of the frameworks that we use today. And so we had this working, by the early 90s, and we developed products with that. And we really liked the fact that we had the same piece of software for research and product. We could hit a key and spit out C code that was basically executable. And eventually we open sourced this in the early 2000s. And that inspired people like Ronan Colbert to actually write a new version of this that was a little updated with the Lua language as the front end, because it was kind of difficult to maintain our own, Lisp language. It was kind of too much work. So, so they, Ronan and two of my students at the time, actually, Clément Farabet and Koray Kevin actually, wrote Torch, Lua Torch. And when I joined FAIR, we had to decide what are we going to use, and Lua was kind of or Lua Torch, or Torch, it was called at the time, Torch 7, was kind of the logical choice. Soumith wasn't there yet at FAIR, but he had experience with this as well, and that's the predecessor of PyTorch. And then it became clear after a while, particularly to Soumith, that people just wanted Python; they just didn't want Lua for some reason, because there is a lot of tools on Python, and people just want to use Python. So Soumith's kind of took it upon himself to basically write a version of Torch that had Python at the front end. But there was something that completely sold me on this project. I was kind of skeptical initially, I must say, and then the thing that just totally sold me was that. He and Ziming Lin and a bunch of other people kind of figured out how to do automatic differentiation for dynamic graphs. And that was something really new that no other tools could do. Things like TensorFlow couldn't do this, for example. That brought a completely new kind of functionality to that system. I said, that's it, this is gonna work. That's the day I in my mind, it clicked that this was gonna work, really.
Do you remember when it was, Soumith?
Yeah, it was 2016 July is when we kind of started actual development of PyTorch. Exactly as Yann said, honestly, the reason was actually twofold. One was I'll give you a couple of fun facts about Lua Torch and the rest of the ecosystem of deep learning frameworks. Then you had to install them by compiling complex code. You had to install GCC or a particular version of it. You had to run some shell scripts, which actually compiled Torch, Cafe, Tiano, take your pick. They all had to be compiled from source and then installed. And then if you had to use the GPU, you had to have the right version of CUDA or cuDNN. Like it was all magic sauce, right? Like just the fact that we had to get it up and running in FP code was a lot of third-party tool work. So starting from that point, one thing was clear. TensorFlow came and they upped the engineering bar for a machine learning framework to be much higher, like to be the actual bar of engineering that it should generally have been. The reason all the previous frameworks weren't there yet was because they all were started by grad students who saw this as a way for them to be more productive, right? Cafe, Torch, Tiano, they were all started in academic research labs by students who mainly wanted to get productive, but the rest of like well-designed product like wasn't really like the main thing for them. So one clear need for PyTorch was just like well packaged, well run, like out of the box, just worked without having to muck around with 20 shell scripts and like they failing. Like that was one. The other was, as Yann said, one big observation that I was working on a few projects then in research. And one thing that was clear was from 2012 onwards towards more 2015, 2016, people instead of in 2012 and before, people were very clever in the way they built each particular layer. They're like, oh, ReLU, like let's build ReLU and make like this a very clever thing. Let's build max pooling. And so the way they were let's build a very clever loss function. The way they were publishing progress was mostly around individual pieces. So the dictionary size of the ways in which you assembled modules didn't matter as much. But as all of the easy wins in the way you formulate individual pieces were taken away, people started trying to put together these pieces in very, very complicated ways. And in LuaTorch, I kid you not, you actually had to write gradients by hand for each set of layers that you put together in a new complex way. So just writing gradients by hand for some of these things was just non-trivial. So from that observation, we thought to write PyTorch to completely support dynamically putting together neural networks to a point where we don't separate out code from neural networks. Like neural networks is code and code is neural networks. And that's pretty much one of the big motivations for us. And so, yeah, two of these motivations was how we ended up wanting to start PyTorch.
And so talk about the early days of adoption, because I think, whenever you see something successful, people sort of always forget the early days and think it was always successful. But there's always that beginning part where we had some good ideas, thought, the library design was based on, as Yann said, decades of work. So the library design was really solid. Plus you added some things on top, plus it's in Python. But what did, the launch of the .8, .9, 1.0 look like in terms of adoption internally and externally in the early days?
That's a good question. It was a lot of iterating, taking feedback. So we started PyTorch actually as a group of people who were working on Torch 7 at the time, publicly on GitHub. And we said, hey, like, how do we survive as a product? How do we build for the next stage? And so about 20 of us, like we would spend, like some of us were employed full-time and a lot of us were just like spending nights and weekends hacking on what could be the next version. And we prototyped things a lot. At some point, Adam Pashka, who was at that time a first-year undergrad in Warsaw, he was in part of the Torch community. He said, hey, I'm looking for an internship. And I said, well, why don't you come and build this full-time with me and Sam, and we'll collect a few more people. And that's how we started, with the raw ambition that, well, let's just build a next version of Torch to be what like we want and what the community wants. But a big part of, I would say, our success was before PyTorch publicly launched. So every week, we built like the initial prototype in about a month or month and a half. And after that, every week we would invite 5 of our friends to try out PyTorch. And by try out, it wasn't even like, oh, can you try it for an hour? It was like, hey, can you use this going forward for your research and see if you have any problems? And I think there was a very high level of trust our friends had in us, which we were very glad for. And they helped, they gave us great feedback. And we would, within a week, turn around 20, 30 fixes, features, improvements, to then invite another set like of 5 friends while keeping these existing people. So, but the day of the PyTorch launch, we had about 100 high quality, like at this point, very famous machine learning scientists who used PyTorch and improved upon it for about 6 months or so. So for us, like post-launch was actually much easier in that it like launch actually felt like half the people were already sold on already using PyTorch. And at the time of PyTorch's launch, PyTorch already had a few citations because papers were published on top of PyTorch even before public launch. And since launch, actually that ended up becoming a critical flywheel that people saw that a bunch of people were already using it at launch, and then they were excited and they published work. We spent a lot of time working on our Twitter social channel, making sure that as we discover people using PyTorch in interesting ways, that we would make sure that was known to the world. And that was pretty much the growth phase of PyTorch. And it was somewhat evident to us within about a month or two that PyTorch was going to be successful and big. Not this big, but like it was going to be big.
So there's so many things I want to follow up on here. And Lin, I want to bring you into the conversation as well in just a second here. But before we do that, I think one thing you said to me that is really interesting is I think often people look at these things and they're trying to find what's the one thing that made this thing successful. What's the one feature or attribute of the team. But what you're really saying is it was an obsessive focus on the customer and looking at the people using the product and saying, what do they need? And getting their feedback and then implementing it. We used it in the early days in a week. So they turn around and get it. So it's really crafted for the customer. And that's a spirit, I think, that really defined PyTorch in the early days. And Lin, I'm curious, as PyTorch has grown and scaled and you've gotten involved and we've expanded the customer base from not just researchers where it was in the early days, but now as the tool of choice for production and engineering, it's a very wide set of requirements. How then have you looked at trying to keep that ethos of customer-centric focus when the footprint is expanded so widely?
Yeah, so definitely, I think PyTorch started as the kind of laser focus on the set of customers, special researchers need, right? So as around, I think it's around like the time of 2018, that's where we see a significant amount of replication effort. The slew of research models enters production, experimentation, eventually getting to launch. So that's the time it becomes clear that research is a leading indicator of production workload patterns. It's also interesting around the time where there are many discussions on AI research reproducibility, and actually it's a critical topic for production in retrospect, because more and more machine learning practitioners are asking for easy way to replicate external research ideas into their production setting. So at that time, having a different framework for research and for production prevents moving fast in replicating ideas. That's when we bet on one framework to bridge research and production. Schroepfer, I think you play a critical role in making this executive call and to accelerate this transition. Interestingly, we didn't realize how big this effort is at that time. So we not only like merged Cafe 2 and PyTorch into one, we also revamped entire Cafe 2 ecosystem to PyTorch ecosystem, from authoring to end-to-end platform and infrastructure, including feature engineering, training platform, serving platform, data pre-processing, model optimization, so on and so forth. So I would say this journey is actually a fantastic journey, because it's not just about a deep learning framework. It's actually about machine learning ecosystem. And also continuing down this journey around the time, like 2 years down the road, late 2019 to 2020, we actually find out machine learning practitioners in product teams, they are pushing boundaries in modeling innovation instead of just replicating ideas from research. And that's fascinating. The driving force seems like there's a very rigorous product competition in the industry, where much of the competitive advantage lies in the advancement of AI algorithms, such as transformers, with a various different applications of transformer, deep retrieval, graph learning, user history modeling, and so on and so forth. And this innovation involves from content standing to a much more high-stake conservative space like ranking. And that's when we realize, oh my God, the speed of iteration and innovation is critical to product setting, not just research. And the Soumith initial idea of laser focus on customer need and really free people from this tedious work into kind of focus their cognitive bandwidth into innovation, also applicable to critical to the production setting. So we double down on building tools and build out PyTorch to accelerate the speed of iteration. However, because of the dynamism, the dynamic nature of modern innovation, as Soumith just mentioned, it's really hard to predict accurately what to optimize for, in this stage. So we took the similar approach to iterate together with our customers here, in the ML practitioners as well as researchers initially, and the focus on modularity and composability. And at the same time, also this speed of iteration requirement drove a big push on AI hardware innovation. It's great to see quite drastic strategic evolution in AI hardware, both at Meta and in the industry.
Awesome. Well, Yann, kind of going back to you painted this picture that sounded like this just happy, long evolution with no bumps and along the way. And that's not my memory of this situation at all. So I'm going to put you on the spot here a little bit and talk a little bit about, some of the challenges and the arguments about, we're talking about dev tools and everyone's got their own opinion and their favorite programming language and their favorite API. Like, take us through a little bit, what that process was actually like, getting from Torch 7, Lua Torch into PyTorch, and sort of getting everyone, on board with where we are today.
Yeah, I mean, this is a struggle that is not actually completely resolved, in the sense that the requirements for like the perfect development environment for this kind of stuff evolves all the time, and it could be that 5 years down the line, PyTorch will be obsolete and something else will have to be built, probably earlier than this, actually. So one thing I struggled with when I was at AT&T with Leon is this idea that we could have a unique platform, a unified platform for research that would be flexible, would have interpreted interactive language with graphics and all that stuff. And at the same time, you could essentially compile it into production code. And we spent a huge amount of time writing compilers for that when we were at AT&T. With our colleagues, and we attempted to try to do this with Lua Torch, the idea of actually writing a Lua compiler to kind of make it production ready. But people just didn't want to use Lua, and so when you tell people, engineers, here is the programming language you have to use now, and they say, I hate it. There's nothing you can do, basically, right? And then the rest of the world was, writing libraries for Python. We also considered Julia, which at the time was really fledgling. Now it's much better. Some people suggested JavaScript, actually, because, there are really good compilers for JavaScript. And so we thought about all of those things. We went along with PyTorch for a while, but the engineers hated it. And so what happened, and you remember that very well, I'm sure, Shred, the engineering side of the house basically split up, and we basically didn't want to use Torch, and started implementing Caffe 2 on the basis of Caffe from Berkeley, and that became kind of the platform for developing engineering products. And I saw this as kind of a personal failure, not having been able to kind of convince people that we should have a unique platform for both, because I was seeing kind of a boundary, a sort of an obstacle sort of being built between research and engineering. And I know that, wasn't good in the long run. And it wasn't clear at all that PyTorch was going to fix this initially. In fact, probably the success of PyTorch was due to the fact that it didn't even try to cater to engineering at first, basically just focusing on the research community, where it became extremely successful. And then, it became possible to say, well, okay, we're going to write Torch script, and, we're going to kind of write a whole bunch of primitives, and we're going to be able to export with Onyx, and, there's all those things that kind of make it usable for production. And now it's become kind of the internal standard, but it took years. It wasn't that easy. And there's probably a space
still not easy.
People with completely alternative approaches to those systems, kind of minimal systems, for example, that are purely C++, for example, or languages that compile, in a better way than Python, that are better designed as kind of efficient languages. We don't know yet. This could move in a lot of different ways.
Well, Lin, I'm curious to get your up-to-date views on this, because I remember these heated debates with Yann back in the day, and it was sort of can you actually build a system that can span the requirements gap? Because production means, every ounce of performance matters, every ounce of reliability matters. You need to really instrument it to know what's going on in production, and research means like speed and flexibility from the user, and these are to some degree conflicting goals for the design center of any system. And so, the fact that we think we can actually have one system do both of them, and to me is slightly surprising. And I'm just curious as to, why is this working, or where are the challenges, and where do you think we need to go to make sure we can still make sure it's a great tool for rapid experimentation, but suitable for production?
Yeah, so this is a very complicated topic. And until today, I would say the tension between designing for research, both foundational research and practical research, which heavily skewed towards flexibility, and the design of optimizing for efficiency and performance and stability. The goals are not always aligned, and often actually at opposite end. And I would say it's a journey for the team to actually walk through, and we're still working on this journey to today to kind of move forward. I think probably, long story short, one key element for us to kind of walk this journey very uniquely in the industry, and I would say by now is still quite successful, is that we laser focus on modularity and composability, and by providing those modular and composable primitives in a reliable, stable and performant way. The reason is it's really hard to predict where the workload shape look like because of dynamism of AI innovation. So we do not want to kind of put our opinion ahead of the curve. Instead, just kind of put those toolkits out to make sure our users can achieve their goals in a flexible way, but also, when they move the needle for research production, it is highly performing, it's highly scalable, it's highly efficient. So I think we're still navigating this balance. It's a very fine balance to strike. And so far, the team has been doing a good job there. But I would say it's not a smooth journey at all, Shep.
Okay. Well, I'm going to put you all on the spot and ask you to make some predictions of the future. We're at about the 5-year mark of the origin of PyTorch. Where do you think we'll be in terms of, AI frameworks and AI overall in 5 years from now? Yann, I'm going to put you on the spot first and give us your prediction for 2027 and what it's going to look like.
Well, I wish I knew, really, but there's a number of different possible paths, right? So one is things like PyTorch, like basically with the Python front end, are kind of brought to the point where it doesn't matter anymore what front end language you're using. There is like good enough compilers that can basically compile anything you want, and you get efficient production code, and the machines become so powerful that it doesn't matter anymore. So I think, and there may be a whole ecosystem that is built to actually support this sort of type of model of programming, where you basically have you have two languages, right? You have the front-end language that most people use, and then you have kind of the back-end language that a lot of people write sort of library functions for, but you almost never touch. And when you need to kind of write something efficient, there's a compiler that takes care of it, basically, right? So that would be one path, probably the path of least resistance. There's another possible path, and you see the beginning of it with JAX. So JAX is more kind of minimal than PyTorch in many ways. It's kind of a little kind of lower level. To some extent, gives more flexibility. In other ways, doesn't. Dynamic graphs are more difficult. But that might be kind of a direction where kind of things kind of crunch down to something a little simpler, particularly for research. There's another option, which is a completely new language. So there've been attempts at this at various points. At Google, for example, basically marrying TensorFlow and Swift and things like that. Could be Julia. Julia is making progress. Now there is a lot of support for tensors that are very similar to PyTorch and automatic differentiation. So it could go that way, but perhaps among certain community, particularly in like scientific computing. Not so much AI machine learning proper, but more like scientific computing, and it will creep into machine. And then perhaps there'll be other platforms that are completely kind of C++ based or something like that. Personally, I'm longing for Lisp. I love Lisp. But okay, the world has moved. What I like about Lisp though is that it's a programmable programming language, right? Programs are manipulable easily, which most other languages don't have. So that's what I like about it. It makes it very flexible. But it's another generation, I'm afraid.
Yeah, I'll take your odds on a new programming language or Julia over Lisp. Unfortunately, Yann, would be my prediction. But all right, I'm going to go to you, Soumith. What does 2027 look like?
I have two main predictions. One is representation engineering. So taking models like GPT-3 or XLM or like the state-of-the-art ResNets, like multimodal models like CLIP, you start from them and then you combine them in various ways to build applications that that get much more intelligent. And just like you have a machine learning engineer and a research scientist, because this space is kind of like how you have integration engineers in robotics or electrical engineering. The space needs a lot of tuning at the end. I think there will be certain kinds of engineers that will pop up, and they all need to socialize and talk and share their representations and models and ways in which they can combine them somewhere. So I think there will be either a social platform or a combination of a framework and a social platform that's going to be very important for these people to talk to each other and work with each other and have jobs for each other, have a marketplace, all that stuff. I think that will happen regardless of the innovation on the model side. And on the other part, on the model side, I think there's two possibilities. One is we continue innovating in how our models are shaped and constructed and built. And if we continue innovating there, so every 3 years for the last decade or so, we've had the state-of-the-art architecture be completely wackily different, right? Transformers are from 3 years ago, ResNets for 3 years before that. And LSTMs and ResNets were about the same. LSTMs came back into fashion at that time. 3 years before that, ConNets came back into fashion. This year, people are saying MLPs actually are good enough. I think there's a certain level of innovation in models happening that is fundamental. But at the same time, it's unclear whether this level of innovation will continue. Let's just take the scenario where there's only transformers or ConNets, right? If there's only two classes of architectures, then the frameworks don't need to have 2,000 functions to model these kinds of architectures. The frameworks can be specialized vertically integrated engines that are much more efficient, much more vertically integrated to just consume these architectures and nothing else. And so the shapes and size of the frameworks will be very different. Now, if that innovation continues, where you're going to see different kinds of models, second order models where you need to compute Hessians or things like that JAX is really good at, then frameworks will continue to be broad stroke. That is, they will have that wide API and a broad amount of generality. So it's unclear to me which direction we will go in. Future will tell, but I think it could be one of these two.
Lin, you're up. What does 2027 look like?
I think from now to 5 years down the road, now we're in kind of highly fragmented machine learning ecosystem era. But because a lot of application development and innovation are heavily happening on the cloud, it will accelerate the consolidation and into a consistent set of ecosystem. And that's where I think if we are doing a good job, standardize the integration API and make PyTorch the centerpiece of this consolidation journey, then we will be able to successfully build out a PyTorch ecosystem, leveraging the cloud convenience and be the ultimate platform for the larger audience. And the second, I think the next 5 years, there will be heavy commercialization of AI that's happening in the industry. So that's just inevitably means a lot of investment in enabling businesses and the vertical solutions in solving the problem. And those problems inevitably is going to be complex problem. Complex decision-making requires multiple sources of content, data content, multiple angle dimensions of decision making. So it's not going to be a single modular solution space. It's going to be complex multi-modular solution space. And I would love PyTorch to play a significant role in entering that domain as well.
Awesome. Well, thank you all for joining us today. I mean, we could talk for another 2 hours, but at some point we have to let every one of you get back to work. It's really awesome to hear the sort of the early, middle, and the future of both PyTorch and AI frameworks from all of you. So thanks for joining us this week on Schroepfer Tech and talking about PyTorch's 5th anniversary.
Thanks, Schroepfer.
Thanks, Schroepfer.
Thank you, Schroepfer.